Hi dear students, today we have again come with another video of class 11. In the previous video we have discussed about significant figures, and today we have to discuss about the last part of units and measurements. Okay, that is error calculation. Now before discussing about error calculation, I'm just telling a little introduction about this. See, in this chapter, we have seen that we want to measure a physical quantity. Definitely, whatever the things we want to measure, that seems to be the correct, because we want to get the correct value of the measurement what we are going to do for a physical quantity. But you see, all the time we cannot able to get the correct value. Maybe there are some reasons that there are little bit of mistakes or little bit of errors in our measurement. Okay, our target is how to reduce it. Okay, so we have to discuss about error. It's a very important part for you, because whenever the school get open, you will be taken to a lab, because in physics here definitely you have to do the practical. Maybe in class 9 and 10 you have not taken practical seriously, but in class 11 and 12 you have to take it very seriously. And this measurement, whatever the things you want to measure in lab, there also you have to measure the error. So how you have to measure the error, what is error, that we have to see here. So in starting the error, we have to learn about two terms. First one is accuracy. What is accuracy? Just now I have told. That is our desire to get closeness of the true value in a measurement. Means whenever we have to measure something, we just want to get the correct value. Maybe there are some problems so that we cannot able to get the correct one. So our target is to get closer to the correct value. So that one is known as accuracy. Okay, along with accuracy, one another term has come, that is precision. What is precision? See, precision is known as the limit of measuring the smallest value. Limit of measuring the smallest value. What is it? I'm just trying to making you remember of a simple definition of class 9 you have read. Okay, mainly I'm talking about class 9 ICSE student. For CBSE student also I don't have any problem. I think you are not having any problem, because whatever the things we're going to discuss, you know that. That is, whenever we just try to measure something by an instrument, so in that instrument there should be the scaling, and in the scaling we have seen one smallest value of the scale, by which the smallest length, if I'm talking about a scale, you can able to measure. Whatever the general scale we have seen, so there a smallest value you have to measure from it, that is 0.1 centimeter. Okay, and it is known as least count. Okay, precision tells us that limit of measuring the smallest value. If the limit is smaller, then the precision will be more, and if the precision is more, then your value should be more accurate. What is it? Assume one scale is given to you, that's least count is 0.1 centimeter, and by that you have measured a length, that is 5.2 centimeter, one length. Okay, another time one another scale is given whose least count is 0.01 centimeter, that is the least count of the second scale, and whenever you have measured the value has come in 5.19. Okay, this value is more accurate compared to the value we have get previous. Now here I am just making you remember that we have learned in the previous video significant figures. And now you are doubting also that times of what is the need of learning significant figures. You see here, more the accurate value, more the number of significant figures. Here also for list count, when here we have to see the significant figure is 1, whenever we have to come here, the significant figure here also it is 1, okay, but whenever we have got the digit, here the significant figure is changed, it is 3. Why? What is the reason? That means if the list count is less, then your significant figures will be more. And if the significant figures are more, then your value should be more accurate. One another doubt you have asked several times that, sir, for the case of constants, the last thing I have told, for the case of constants like gravitational constant, Planck's constant, that case we have told their significant figures are infinity, infinite number of significant figures. Why? I have already told, more the significant numbers or significant figures, more the accuracy. So as the significant figure is infinity, I am talking about a constant, that means that one is fixed, that cannot be changed, it is accurately measured. That value of the constant is accurately measured, and that's why its significant figures are infinity. Okay, so it is all about precision, and here we are just trying to tell that precision is nothing but correlated with the least count of a measurement. Least count means the smallest value you can able to measure. So more lesser the least count, more higher the precision, and accuracy will be more. Okay, so it is, before error calculation we need to learn these two things, and for that reason only we have to learn the significant figures. Now coming to the next part, which is more interesting, that is error. What is error? Definitely whenever we are talking about error, it is a difference between true value to measured value. That is the error. What is the exact value of a measurement to the measured value, means whatever we have measured, this difference, that is error, and our target is to reduce this, and then the value will be more accurate. And one step to reduce this, we have to get an instrument whose limit of measuring smallest value, that is the least count, should be smaller. More smaller value, more accurate measurement. Okay, now the question has come, why there are errors coming in any measurement? We don't want to make any error, we don't want to make any mistake, but then also why the error has come? So based on their what we can say, based on their coming, based on the introduction of error, we can divide error into 4 parts. We can divide error into 4 parts. First one, it is systematic error. Systematic error. Second, random error. No reason. It is random error. Third one, least count error. So least count you have already learned. And the last one is known as gross error. Okay, 4 types of errors, or we can say 4 sources of errors, that by that way the error can be introduced in an measurement. Okay, so we will just try to individually interrogate each one. What is systematic error? So we have to start from here. Okay, so I'm erasing this thing. If you want to write, pause the video here and write it. So first we will go for systematic error. So by the name only you will understand, it has come, more or less it is related with the instrument. Okay, and the system which we have used to measure a value of a physical quantity. So the whole system we have followed, in that system maybe there are some error. What type of error can come? If I'm talking about systematic error, the first error can come, that is known as instrumental error, which is very much common for us. What instrument you have to use, maybe there is some problem in that instrument, maybe what scale you have used to measure the length, the scaling is not proper, maybe the scale is broken in one place. So that's why from that point the error can come, that is instrumental error. Number 2, personal error, which is very common. The person who is doing that practical, who's doing the measurement, maybe some error it is done by the person. So that's why this error is known as personal errors. Number 3, imperfections in technique. Whenever we have to measure something by an instrument, there may be a desired technique you have to follow. If you have not followed the techniques properly, then also there may be some error. Then you might be asking, sir, it is one kind of personal error. No, it is, I'm just writing it separately. Personal error is dealing with that maybe whatever the mistakes you have done for your first experiment, whenever I have done, maybe that experiment, that error is not done by me because I have done it for a long time. So the chance of error for me, it is little lesser. If any another teacher has come who is more experienced than me, so his chance of error is more less. Okay. Imperfection in technique means some technique is followed by that person, some technique is followed by me. Maybe his technique is more accurate, but both of our target is to get the desired value. So if the technique is different, okay, maybe after making the connection I have on the switch, and maybe the person have on the switch and doing the connection in online, okay, there will be a chance of accident. But this is also another technique to do one experiment. I'm talking about electrical experiment. Okay, so this is a technique, that is the imperfection in technique. And number 3, that is very common, that is external causes. External causes. Maybe one experiment when you have done, what value you have got, we have just followed same technique or same things are there. Maybe the same practical is done by same person in 2 different time. Maybe that time the temperature is 10. Maybe that time the pressure, the atmospheric pressure is changed. Maybe that time the humidity is changed. And that is also giving an effect on the measurement of a value. And that is known as external causes. Now, what the 4 things we have written, that instrumental error that can be solved by us by making some things in the instrument or by taking a new instrument. Personal error, by doing several times you can get more accurate way to do, so your personal error should be less. Imperfection in technique, that also if you do and if you learn the technique from the book first and then you do, then also it is solved. And external causes, if you taking into account that whenever we have to do, we have to take the temperature 25 degrees centigrade, pressure, that atmospheric pressure and something like that, so that external causes you have to take, that is also taken by you. Now you will see this cannot be changed by measuring, that can be done before experiment. Whatever the things I have told, that you will change this before experiment. Now whenever we have doing the experiment, that different kind of errors can come, and that one we have to discuss for random error. What is random error? Maybe you have done a same experiment, you are same person, you are doing it for 4 different times, and you are measuring, assume a length. So first time the length is coming 5.29, second time the measurement has come 5.3, and third time it is coming 5.28. The person you same, but you have done it different time, you will get different values. You don't know why. You have taken same instrument, your error, you have the same person, so I don't think there should be error in you. Technique, you have read it from the book, and external causes, make sure that the external causes are same, then also the values are different. For that reason, that is known as random error. What is random error? Random error is nothing but when different values are coming when the same experiment is done in different times. Different values are coming when you have done same experiment in different times. That is known as random error. And one thing I'm telling, whatever the calculation we have to do, that to cure that random error, because this one we cannot cure. That instrument, everything you can cure, but whatever the things that is done before the experiment, but after the experiment what the things has come, that is random error, and that can be solved by calculation only. Okay, so whatever the calculation, error calculation we have to do, that the error calculation for random errors only. Now coming to the list count error. So list count, I have already told, the smallest value, okay, of the measurement. But whatever the smallest value we have taken, assume I have taken different instrument whose list count are different, so the error is coming in that measurement for different values of the list count. Okay, so list count error is very much common with different instruments. If you have taken, if you have taken same instrument, then the list count error will not give any effect to you. Rather, it may be possible. I have given an example for the scale. Assume the scale has been decayed in one portion, okay, and due to the friction, and so that there some error has come for the measurement of the first value. There is also error known as list count error. But if you change the scale, then your list count error can be solved. Okay, and gross error. Again, gross error is nothing but the personal error. It is one kind of personal error, and it is happening due to the carelessness. Whenever you have to do any experiment, you have to be more careful. If there is some carelessness in the experiment, then the gross error has come, and that error, it cannot be solved. Okay, so whenever the experiment you have to do, you should be more cautious about that experiment. Okay, so these are the kind of ways by which the error can come, whatever the measurement you have done. Okay, so there are 4 kind of errors are there, but by calculation we can eliminate only the random errors. Rest of the errors, that can be eliminated by you by getting proper knowledge, proper technique, and proper instrument, and by that only you can solve that error. And only random error we can solve it by calculation. So now our next target is that how the random errors can be resolved. How the random errors can be resolved. Let's see. Okay, so random errors, or we can say random errors calculation, because rest of the error we cannot able to calculate. What the error we can able to calculate, that is random error. So what is random error we have seen already. So how we can get the random errors? So to the get back the correct value from the random errors, we need to find out the absolute value. What is absolute value? Whenever we have done a measurement, in that measurement we need to get the true value. And now the question has come, sir, true value, how do we get it? See, I have given you a stick. I have told you measure it. You have measured it by a scale. Assume you have told, sir, the length is 5.3. Okay. Next day, you have again come. I have told again you measure the stick. You have told, sir, today we have told already it is 5.3 centimeter. Okay, you have told. You have taken it. Nowadays you have told, sir, it is little more than 5.3. So we can take it 5.31 centimeter. Okay. Next day, whenever you have to measure it, you have told, sir, today we have measured, but nowadays we have seen it is 5.29 centimeter. Why? Different time whenever you have to measure, or in same time if you have measured several times, then you see might be your values are not same, and that one is random error. Okay, that error has come due to the several reasons are there. You don't know the particular things that because of that the error has come. The error may come for different reasons, whatever the reasons we have discussed earlier. Okay, so if there are several values has come, what do we have to do? We want to get the absolute value. Absolute value means we want to get the true value. So how we have to get the true value? So true value can be got by taking the mean of the experimental values. Assume you have measured the same length for n number of times. So you will get n number of values. So to get the absolute value, what we have to get? So absolute value we have to take by A average. This bar just signifies that A mean. That should be A1 plus A2 plus A3 plus plus AN divided by N. So whenever we have to take a average or take a mean of it, then we will get almost the correct value. Okay, and by that we can get the absolute value. Okay, so A bar, that is known as absolute value. So as once we have got that absolute value, next we will go for absolute error. What is absolute error? Now whenever we have got that value A, so this A shouldn't be equal with A1, A2, A3 or A. It may equal, but mostly you will not get the accurate same value. There will be a difference. So whenever you have to find the difference, earlier only we have told that error is nothing but true value minus measured value. That is only the error. So measured values we are having A1, A2, A3, and the true value we have got that average one is the true one. So that is A bar. So absolute error means the error itself. So first the absolute error, delta is the difference. You all know that. So delta A1, that is equals to A bar, that is the true value, minus A1, delta A2, that is equals to A bar minus A2, delta A3 equals to A bar minus A3, and if you go for delta AN, that is A bar minus AN. So what we have got? Now we have calculated the errors separately for each of the calculation, because the mean value we have taken the correct one. By that we will get the absolute errors for each measurement. For each measurement you have got the absolute errors. And now one thing I have to told, maybe the value A bar, it is greater than A1, maybe it is less than A1, maybe It is equal to A1. So if it is equal to A1, then delta A1 will be 0. No problem with that. Okay. If it is less than A1, then the value of error is negative. And if it is more than A1, so it is positive. So whatever the value will come, maybe it is positive, negative or 0, we have to write here. And that should be the absolute error. Absolute error can be positive, can be negative. Okay, no problem with that. So if it is coming positive, we have to write plus. If it is coming negative, we have to write minus. Okay, we will see one example, then it will be easier for you. For before that, we have to see how the errors can be calculated. Now, absolute errors we have done. We have already calculated. Now we'll go for the next part, that is mean absolute error. Means we want to find the error in measurement. So the error should be one. We cannot say for different times the errors are different, so that then your measurement will not be appropriate. So for that we need one error. So how do we get one fixed error? So how do we get one fixed value? By getting an average. Here also you have to take an average, that is delta A bar, that is known as absolute error, and that is equals to delta A1 plus delta A2 plus delta A3 plus dot 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 plus delta AN by n, and that will give you mean absolute error, that is the total error in a measurement. Total error in a measurement. Now whenever we have to represent a measurement, then we have to write the measurement can be shown that A equals to A bar, that is the true value, plus minus delta A bar. So this is true value and this is mean absolute error. Okay, and that is the measurement you have done. So your answer will be that whenever we have to measure anything, the measurement will come A bar plus minus delta A bar. So that is the whole measurement we have done. Okay, apart from this also we can able to find the error in two different ways. First one, okay, and it is, you cannot say that it is two types. This is also the same like thing we have done earlier, but it is kind of representation. We can represent the error in two different ways. First one is known as relative error. What is relative error? The relative error is nothing but the ratio of mean absolute error to true value. That is, relative error is basically delta A bar by A bar. That is relative error, which is known as AR, error relative, delta A by A. By that, one very interesting story has come to my mind. In my first school, from where we have started my teaching life, so that school I have taken the class of that time, class 9, 10 and 11. So one day I have given the idea of what type of errors are there. I have told to them what type of errors are there, etc, etc. And the next day I'm just taking a class test, and that time I have given what do you mean by relative error. One student has written that relative error is basically the problem between the relatives we are having, and that answer is still now, whenever I have told that relative error to any of my students, that story I have told, that answer I have got, and that seems to be the best answer in my life. Until now I can able to remember that thing. Okay, so ratio of mean absolute error to the true value, that is known as relative error. And along with it, one thing has come, that is percentage of error, which is very much needed for us, because whenever we have to find an error, we need to see that how much percentage of error is there. Percentage of error is nothing but the percentage of relative error. So what relative error we have find out? So if I multiply with 100, that is delta A by A bar into 100, that will give us the relative error. Okay, so that you can say the calculations of error for the, especially for random errors. So whenever we represent the measurement also, we can represent it in a form of percentage of error, that the measurement of length is 5 centimeter with 2% of error. So 2% of error means delta A by A into 100%, that is equals to 2. Okay, that can be also represented, that if you represent it like a measurement A equals to A bar, that is the true value, plus minus, here percentage of error is AP. Okay, so it is AP in percentage. So we can represent it with the help of absolute error. We can represent the error with the help of percentage of error also. Okay, so these two are different kind of representation, but you see the way we will get delta A bar and A bar, it is mainly by the average. Okay, now you might be thinking, sir, what the things is going on, we can't understand. It is easier if we have done a numerical. So let's start a numerical first, then it will be easier for you. Assume you are measuring time period by the help of simple pendulum. Okay, so simple pendulum, you all know what is simple pendulum. Okay, so this is a pendulum, you are oscillating this one. So in many of the wall clock, the simple pendulum is there. Time period means when it starts from here going this point and again it reaches here, or if you start from here, it comes here and again it reaches here. So that will be one oscillation. If you start it from the point A and when it again reaches to the point A, then that much time is known as the time period. I think you all know that. No need to give more explanation regarding this. So here you have done the measurement, the time period, and whenever you have to measure the time period, definitely you have to measure it for several times. Okay, not like that you have taken one time and you have told it is right. No. Okay, so what measurements we have seen? Let's see. So first value, it is coming, it is T1 equals to 2.63 second. Okay, second value T2, it is 2.56 second. Third value T3, it is 2.42 second. T4, it is coming 2.71 second, and last one it is coming T5, that is 2.80 second. Now you see 5 times you have measured, the 5 different values have come. Why? What is the reason? I have told there is no particular reason. There are 4 kind of errors are there. Mainly the rest of the 3, that is systematic error, least count error and gross error. And by that only what different values have come, that is there in random error. So you see the values are random. What we have to do? We want to find the true value. So true value means the mean, that is T bar. So T bar equals to T1 plus T2 plus T3 plus T4 plus T5 by 5. So 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 by 5. Simply I have taken the average. What it will come? I have already done the numerical, that's why I can write directly. For yourselves, you can use pen and paper and do and calculate it. Otherwise, you can do calculator also if you are a ISC student. If you are a CBSE student, no calculator is allowed. You have to do it by your own. So I have done it earlier by my own. So that is 2.62 seconds. So 2.62 second, that one we have to take. This is a true value. So when the true value has come, then our target is to find out absolute error. That means the each error we have seen. First one, it is delta T1. So delta T1 will be T average minus T1. What is T average? 2.62. T1 2.63. So definitely it will be 0.01 with a minus sign. Okay. Delta T2. Okay. So it is T bar minus T2. So T bar it is 2.62 minus 2.56. So it will come 0.06 and this is positive. Delta T3, that should be T bar minus T3, and here it is 2.62 minus 2.42. Okay, so here it is 0.20. Next, delta T4, T bar minus T4, so it is 2.62 minus 2.71. So 71 means 9, that is 0.09 with a minus sign. Okay. Next we have to come by delta T5, that is T bar minus T5, and it is coming 2.62 minus 2.80. Okay, so here it will come 0.18 with a minus sign. Okay, so these are the absolute errors we have finding out. Okay, now we want to represent it. So to represent it, we want to get the mean absolute error. So the separate absolute error we have got, we will get mean absolute error. Mean absolute error. So you might be thinking there are long hectic process. Yes, error calculation, the procedure, it is hectic, but it is easy. Mean absolute error. So whenever we have to talking about mean absolute error, what the things will come? So it is delta T bar, that is equals to delta T1 plus delta T2 plus delta T3 plus delta T4 plus delta T5 by 5. One thing you have to remember, to write the accurate thing, we have to take a mod. Okay, initially we have not taking about positive and negative one, so that's why we are not discussing about mod. Here you have seen 3 minus value, 2 positive value, but as they are coming minus, you have to write minus. No, in error no minus sign will come, all the things will be added. So we have to take the magnitude of the absolute errors. So if I have taken the magnitude, del T1 it is minus 0.01, so we have to take 0.01 only magnitude, plus 0.06 plus 0.20 plus 0.09 plus 0.18 by 5. Now that average is also done by me earlier, otherwise it is little bit of difficult for me to do, and it is coming 0.11. Okay, and it is also round off value. Actually it is coming 0.108, but rounding off by 2 digit we will get it 0.11. Okay, so that our value should be little more accurate. Now the question has come, how do we represent it? As the absolute mean error or mean absolute error has come, so the measurement will be measurement of time period, it will be equal to t, which is 2.62. and now see, the error has come 0.11. so it may be positive, it may be negative, because we have only taken the magnitude of it. It can be plus, it can be minus, so it can be represented by plus minus 0.1 second. So that is a representation of a measurement. Okay, and along with that we will do two more things, that is relative error, and relative error is delta t bar by t, that is t of r or delta t of r. So what is delta t? 0.11 by 2.62, and that value, if we calculate that value, we have already calculated earlier, it will come 0.04, and apart from 4 there are another more digit, it is actually coming 4198, but we are happy with 0.04. okay, so why? What is the reason? Simple thing, whatever the measurement we have done here, the smallest significant figures are 2, so we will also take the smallest significant figure, so that's why it is 0.04. and last one, percentage of error, and it is 0.04 into 100, that is 4%. so the error in your total measurement, that is 4%. okay, so I think now it is little bit of clear that how we can able to measure the error. okay, thank you.